Hi everyone, in this video we are going to learn how you can create a real-time object detection Android app. So in this video we are going to use the TensorFlow Lite model plus the Camera2 API to directly read the frames from the camera. So let's start this video. So let's just open our Android Studio and we'll create a new empty project. Let's create a empty activity and let's just give a name. I'll say real-time object, and the language I'm going to use is Kotlin language, and let's hit finish. Now here for reading the frames from the camera we have two choices. Either we could go with OpenCV or we can do with Camera2 API. Now here's the thing that we have already created video about how you can read the frames by using OpenCV, but in this video I would like to try something different, so we'll just go with Camera2 API. So in that case our app size will also not increase, since by adding the OpenCV library it is going to drastically increase the size of our app. Okay, the project build is finished. Now let's hit open our manifest. The permission we are going to use for this app will be the camera permission, since we want to read the frames directly from the camera. And other than that we need to handle this permission first. So I'll just come get to the main activity.kt. First of all we'll run get permission function, which we are just going to define now. Now I'll just define this get permission function over here. Now the only thing we need to do over here, we will just first check if context compat check self permission, and for the context we will pass this, and for the permission we will say android dot manifest dot permission dot camera. Now if this is not equal to package manager dot permission granted, then we are going to request for the permission. So we'll say request permission, and it need the array of the permissions we want to request. In our case it's only the single permission, it is a camera permission. Just paste it over here, and just 101 will be the request code. Now when the user is prompted about the camera permission, the callback function which is called on request permission result, and here we are going to check if user have denied to give the permission. We'll again ask the user to give the permission. So we'll say if grant result 0 is not equal to package manager dot permission granted, then we are again going to say get permission. That's all over here. This is for our permission function. Now once we have the camera permission, what we want to do is to read the frames from the camera, right? That's only with the thing we have to do. But let's just define our first UI, on which UI we want to show the frames. So first of all I'm going to just create a very simple relative layout UI, and instead of text view we will have a texture view. Now the texture view is the one which is used to show the stream of something, the video or the frames. So we are going to use texture view. So it will be match parent, and match parent will give ID of texture view, just like that. And we will just get back to our main activity now. Init where texture view of kind of texture view, and I'm going to come over here and I'm going to say texture view is equals to find view by ID r.id.textureView. Now this texture view have a listener attached to it, which will be a surface texture listener, which will going to listen for the surface. Now we need to define this listener first of all. So we'll say object of texture view dot surface view listener. Now you have to hit command N, or I guess control N for Windows, and hit enter. So we need to implement some functions. These 4 functions we need to implement. I'll just get rid of this. We don't have to do anything over here, not anything over here. Now this function on surface texture destroy returns the boolean value, so we're just going to return false over here. Now when the surface texture is available we need to open the camera. So we'll say open camera when the surface texture is available. So we'll just define our open camera function just for now over here, just like that, and everything seems fine over here. We have given the surface texture listener. When the surface is available we need to open the camera. Now how do we open the camera? We are going to use camera manager, which we can just define like over here. We can say camera manager, and we will get the camera manager over here. We'll say camera manager equal to get system services, and you have to pass the service you want. So we'll say context.camera service. Now we are going to typecast it to camera manager. Now using this camera manager we will open our camera, so we'll say camera manager dot open camera. Now it need the camera id, then camera device state callback, and then handler. So we'll say open camera. First of all, id which we can get from camera manager dot camera list id, will just get the 0th camera. For your phone there might be multiple cameras, so index will be 0 1 2 and so on, so you can just check which camera you want to use. Now it needs the state callback, so we'll say camera device dot state callback. So camera dot state callback, and it has to be the object of it, so we'll say object of this, and we will going to define. And for the handler I am just for now going to return set it as null. We will define it later on. Now here we need the functions, so we'll just implement some functions. There are 3 functions this time. Open camera when the camera is opened, on disconnected, and on error. But still you will be getting some error over here. You can just click on this and it will going to ask you to check for the permission, but we have already checked over here. Over here is get permission, so we'll just suppress this because we are sure that we have checked for the permission, so we'll just suppress the missing permission lint. Now let's first define our handler, then we will just do the other stuff. So we'll say let init var handler of kind of handler. I'm going to define my handler just over here. First of all we need our handler thread, so we'll just say handler thread is equal to handler thread, and you have to pass the name. I'll just say video thread. And now this, using this handler thread, I'm going to initiate my handler variable which I have defined. So I'll say handler and have to pass this handler thread dot looper. That's all you have to do. And for this handler we have passed earlier null. For now we will just set handler. Now we are not going to use these functions for now. We are just interested in on open, when the camera device is open. So I will just once again do one thing. I'll just initialize a variable which will be a camera device, and when the camera device is open I'm just going to set camera device equal to p0. Now on this camera device, first of all we need the surface on which we want to stream the frames. Okay, so our surface is this one. So we this is the texture view. From this we are going to get the surface. So first of all we need to have the surface texture, and we can get from the texture view which we have already defined, texture view dot surface texture. And now from this surface texture we will get the surface by just passing it through the surface class, which will be a surface texture, and hit option enter to import this. Enough of this. Now we are going to say this camera device dot create request for a capture. Now this capture request will going to return us a builder. So we'll say, I'll say capture request to camera device dot create capture request. Now it need a template, so we'll say camera device dot template preview, since we want to create a preview request. Now once we have the capture request object, we'll say capture request dot add target. So our target will be surface, so we want to connect the camera device with the surface, and that surface is nothing but this texture view. Now once we have the capture request from this camera device, we are going to create a capture session. So we'll say camera device dot create capture session. Now this capture session need a mutable list of surface, then a callback, and then a handler. So we'll just first of all pass the list of the surface, which is nothing but this surface, and next it need a callback. So we'll just say object of camera device session, camera capture session dot, it's a state callback. We will say this, and for the handler we will again pass the handler which we have already defined. Now this has to implement some methods which is on configured and on field. Now on configured we will have our camera capture session. We are just going to say p0 dot set repeating request, just like that, and it needs the capture request, which is nothing but this capture request dot build, since that is a builder. And for this callback we will just pass null, and for this handler we will pass null for now. Alright, all code looks fine to me, and if we run our app like this now, you should be able to see a video stream of the app. So let's just try to run our app. So our emulator has been started. Let's try to run our app and see if we get any error or not. Our app is crashed. Let's see the reason. Let's click on run, and if I scroll up, the problem is with the handler. Actually, we forgot to start the handler thread, so let's just do that real quick. We'll say handler thread dot start, just like that, and I'll just close the app now, and let's rerun the app. There you go. You can see the stream of the camera in front of you, and our app is running as expected as we want. So I'll just terminate my app right now, and then we will proceed further in the program. So now what is our task? Now we are able to read the camera frames. Now our task is to get the bitmap from that frame, then use our TensorFlow Lite model to produce a prediction, then draw the prediction on the frame, and then show that frame to the user. I hope it makes sense, right? So let's just do the same. So the very first task would be how to get the bitmap from the texture view, right? It's so easy. First of all, you see here we have created is texture view surface texture listener, and in that listener, when the surface texture is updated, it means the texture is updated, meaning new frame has been arrived. So here we can use texture view dot bitmap to get the bitmap from the texture view. Now we need to store this bitmap somewhere and then show that bitmap to the user. So we need a bitmap image view to show the bitmap to the user. We'll just say match parent, and I'll just give the id to it image view as it is. Now what will happen, I will, let me just give you some background to it. Now what will happen, behind this text image view we have the texture view. View will going to give us the bitmap. Now we are going to get that bitmap, produce the prediction, draw the prediction on that bitmap, and then show that bitmap to the image view. So what will be the visible to the user? Image view. Now let's get back to our main activity and define the late init, where over here we'll say image view of kind image view, and here over here I can say image view is equals to find view by id r dot id dot image view. Now once we have the image view, as I said, on surface texture updated, when the texture is updated, we want to get the bitmap from it. So we will also need a bitmap variable. So let's create a bitmap variable of kind of bitmap. Once you have the bitmap, we are going to get back to over here. We are just going to say bitmap is equal to texture view dot bitmap, like that. You have to do that null assertion. So if this texture view is null, this will going to create a null pointer exception error. Now we need our model, so I will just go to tensorflow.org, and here we are going to use this model as we have used in our previous video. I would just recommend you, if you want to learn how to deploy this model, then you can watch the previous video. I have explained in detail. The video I'm talking of is this one, object detection Android app. I will leave the link in the iCard as well as in description. This is very detailed video. I'm going to now go back to object detection, and you have to come over here, download the starter model with metadata. So if you click on this, you will get the starter model. So this is the model which you will get, and other than that we need this labels.txt which contains all the label this model can predict. So we need to copy this labels.txt first. You can get this labels.txt in down description. There will be a link for this also. You have to click on project, then real-time app, and in the source, in the main, you have to create a new directory, and we'll call this directory assets. Make sure you call it as it is, and I'll just paste this labels.txt in over here. Now once you have labels.txt, the next thing we need to import is our TensorFlow Lite model. So I'll just click on file, new, other, then TensorFlow Lite model, and click on this folder icon and just locate wherever it is. Here is our SSD mobile net, so I'll just click on open and hit finish. It will take some time to install the dependencies. Now once you have this done, everything done, we are going to copy this sample code. Now somehow if it is not automatically open in your case, you can go to project and just click on Android, and in the app, in the ML, double click on this model. So again it will open over here. So I'll just copy this all thing, I'll just paste all the code over here only. I'll just get rid of these comments. Now we have to import this, hit option enter to import, and for this context place this, and for this sensor image hit import. And other than that, we are getting this as the problem. Actually you will just define this model above, so I'll just cut this out from here, and in this on create I'm going to define my model over here, and my model is going to be a global. You will, in a minute you will just come to know why. So I'll just say let init var model of kind ssd net metadata 1. Okay, now I'm not going to close my model over here after making the prediction. When I'm going to close on destroy function, so when the app is destroyed, then I'm going to close my model. So I'll just say model.close when the app is destroyed. Now the last thing we need to do is this bitmap has to be of 300 by 300 pixel, but here you can see it could be of any resolution of your camera reading from the back camera or front camera. So we need to resize this image before sending this for prediction up to 300 by 300 resolution. So for that we are going to use image processor. So I'll just create a image processor, and you have to import it, and I'm going to define the image processor just over here. I'll say image processor equal to processor dot builder dot add, and I'm going to add the resize op, and you have to import it, and the height and width is going to be 300 by 300, and the method is going to be bilinear, or you can do nearest neighbor also. And finally I'm going to say build. Now once we have the image processor, I'm going to get back in over here. I'll say image is equals to image processor dot process this image, and this has to be variable since we are reassigning the value. Now we will have the outputs in the locations, classes, scores, and number of detections. So I will just go back. So now once we have the output, we need to draw the rectangle and the prediction on the bitmap, and then we want to show that bitmap to the user. So for that purpose we are going to use canvas. So I'll say value canvas is equals to canvas, and this need a bitmap like this, and I need to import the library. Now this bitmap I'm passing over here, it has to be mutable, but this bitmap I have passed is immutable, so I need to pass a mutable bitmap. So I will just create a mutable bitmap real quick. I'll say bitmap dot copy, and I'll just create it a variable, and bitmap dot copy, and now it needs the configuration. So I'll say config dot argb888, and then finally it need a boolean variable value which is true, is mutable, will be true in this case. Now other than that we need a paint also to define the stroke width and the color and all. So I'll just real quick create a paint. So I'll say value paint is equals to paint, just like that. Everything seems fine over here. Now the only thing left is to use these location, classes, and scores to draw the predictions. So I'll just save the time and real quick copy the code from this app which we have already created in the previous video. I will explain it to you, don't worry. I will just copy from here up to here, and I'll just paste it just below over here. We got some errors. Actually we need to convert this buffer to float array. Just convert all of them to float array so that we can access them by index. So float array, float array, float array. And then finally this colors also, I will just copy this list, colors dot list, from here. I will just paste it to the top. So first of all, what is colors? This is a list of all the colors. This is not necessary, you will just come to know in a bit. Now once we have the array like location array, classes array, scores array, what we are doing, we are iterating in the scores, which is the confidence associated with each predicted class. Okay, and other than that we are just storing the height and width of our bitmap which we are showing to the user. and we are setting the text width and the stroke width of the paint proportional to the whatever the height of the bitmap is. And other than that, we have our x variable. You will come to know why we are using it. And before that, why we are having this height and width, because this locations, which is the location where the triangle rectangle has to be placed of the object, is normalized between 0 to 1. So we need to scale that value from whatever the height and width is. So that's why we will multiply all the values by height and width of the bitmap to scale them. Now we are iterating for each class which has been predicted, and we are saying if the confidence is greater than 50%. And also you see over here that we are assigning x index for now. Now once the confidence of the particular category is greater than 50%, we are setting the paint color. This list, remember, we have created above, so we'll just get the index so that the output is colorful. So we are setting the paint color from the color list we have already defined. We are setting the paint style to be stroke, since we want to draw the rectangle of stroke, not the filled one rectangle, so that's why this is stroke. And when we are drawing the text, we are making it filled, since we want to draw the text filled one, not the stroke one. And once we have the properties assigned to our paint, we are drawing a rectangle on our canvas, which we have already defined over here. Now for the canvas, we are getting the locations in this manner. This is y, then x location, then again y, and then x location, and then we are scaling it by multiplying with its width and height, and so on. And for drawing the text, we are drawing on the top left corner. We are just copying this location over here, as you can see, and we are passing this paint. And other than that, we are converting this confidence, which is situated in this fl variable, we are converting it to string. And other than that, we are getting the class of particular predictions. Now the last thing we have to define is the labels. So I'll just go back to over here. I'll just say late init var labels is the type of list of string. And I'll just come back to over here. I'll say labels equals to file util dot, and you have to import it from the TensorFlow Lite. File util dot load labels, and context will be this, and the name is labels.txt, which we have already copied to the assets folder. So that's all what we are doing. And then finally, once all the predictions are drawn on the image, we are showing the image to the user using this image view, which we have over here. Now if we run our app like this, you should have what we intended to make in this video. So I'll just run the emulator now and we will see. So you can see that it is running as expected, and it is able to predict me as a person and my phone as a cell phone or sometimes remote. So that's it, what we intended to build in this video. The frame rates are dropped because I am recording, and this whole Android Studio is running, and this emulator is running in just 8 GB of memory. If you run this app on a actual physical device, you should be getting very good frames, about 20 to 25 frames per second. So I will just end this video right over here, and I guess you should be able to understand what we built in this video. And still, if you have any queries, you can ask them in down comment section. So I'll just end this video right over here. Till then, goodbye, and I'll catch you in the next video.